So, one last section to test. We will do chapter 15 next week. But with finals the week after. I'm not gonna put it on the test. We are doing graphing rational functions. This is 14.4 in Blakely's book. Now we're gonna take it further than he did. I was just heckling him via text on, he really fucking just like chumped out. He's like, yeah, I tend to teach that shit in calculus, so I'm like, fuck that, we're doing it now. All right, so f of x equals 1 over x. Rational function. Rational functions have x's in the denominator. The denominator. And turns out when you graph these, I'll put the 1, 1, -1, -1 in here. If I put in 1, I get 1. If I put in -1, I get -1. So those points are on there, but as we get closer to 0, our graph approaches the y-axis but does not cross it. As x gets really large, it approaches the x-axis, but it doesn't cross it. And when x gets really negative, it approaches the x-axis again, but doesn't cross it. If I put a little dash line right there, and a dash line right here, and the only reason it's not on the black line is so that you can see it. It should be on the black line. Lines that get approached but aren't crossed are called asymptotes. It's a great word. Asymptotes. So here, x equals 0 is a vertical asymptote. Which I'm gonna start abbreviating v dot a dot because you're gonna get tired of writing vertical asymptote real quickly. And the y equals 0 line, or the x-axis, is a horizontal asymptote. And I'm gonna call that HA. There's a lot right there. If you've heard asymptotes, there's a lot of writing you don't need to write. You already know what it is. But I can't assume that anyone knows what an asymptote is in here, so.
I get consistently y equals 0 and x equals 0 mixed up, so I'm like, I need to remind you.
The problem, it's easy to get mixed up
Yeah,
because y equals 0 is the x-axis.
yeah,
It's the opposite fucking letter.
yeah.
X equals 0 is the y-axis, it's the opposite letter.
Now you're confusing.
Yeah, it is. I agree. The more you deal with those types of lines, the more used to it you get, and the less confusing it becomes. So these vertical asymptotes here, these occur where the denominator equals 0. So we had f of x equals 1 over x. I set the denominator equal to 0, and bam, that's my vertical asymptote. If I have another function here, g of x is 1 over x plus 2, x minus 3. I set that bottom equal to 0. I'll do it over here so I got room to graph it. And I get x equals -2 or 3. The black lines are my asymptotes. This is the x equals -2 line. It will be a vertical asymptote. X equals 3 line is a vertical asymptote. And we use dashed or dotted lines to show asymptotes. So the vertical asymptotes are pretty easy. We've done them several times throughout the semester, find where the denominator equals 0. Those are our bad juju numbers, I like to call them. Here they make asymptotes. What about the horizontal asymptotes? Where did that come from? So let's talk about, is everyone ready? Everyone okay with this? Horizontal asymptotes. So to do it, I'm gonna set up like a generic equation for this. I'm gonna have ax to the n on top. Plus a bunch of shit. Bx to the m on bottom. Plus a bunch of other stuff. I'll say plus terms that have lower exponents. So that ax to the n is called the leading term on top. And bx to the m is leading term on bottom. And they calculate biggest exponents for their sides. We kind of need to bring that up because where the horizontal asymptotes are very much depends on n and m. So option A, option 1. If m is greater than n, then y equals 0 is our horizontal asymptote. That's like f of x equals 1 over x, which is like x to the 0 over x to the 1. That's my m, that's my n. M equals 1 is greater than n equals 0. So if the bottom is. The bottom has a larger exponent than the top. If I would put it in English words. Option 2. If M equals N. Then Y equals A over B. Is our HA. Still horizontal line. And this is kind of like it, maybe if I had f of x equals x squared minus 1 over x squared plus 1. It's the same degree on top and bottom. If I divided by. Or if I multiply by 1 over x squared on top and bottom. We would have 1 minus 1 over x squared. Over 1 plus 1 over x squared. And we discussed this earlier for n behavior. As x gets really large. As x goes towards infinity. These go towards 0. So this really only looks like 1 over 1. Which is A over B. That's very much how it works and why it works that way. In fact, your first week or 2 of calculus, you will have rational functions in there. And this is a strategy you're gonna take. Multiplying by 1 over x to the highest exponent to see what happens. This is a common strategy in beginning calculus. So you'll see it again, not next semester, but the semester after. Important thing that you can do right now, you can do the multiplying by the 1 over x squared like I did. Or just focus on the coefficients. 1 over 1. But it requires the same degree on top and bottom. Same degree or exponent on top and bottom. Option 3. M is less than n, so top has bigger exponents than bottom. John Blakely's textbook does not cover this. Your homework will have it. So we'll do that section last. We were doing examples of this in 335. We actually jumped to the hardship last chapter, or in the last class. Okay, so that's how we find horizontal asymptotes. Just checking exponents. So how do we graph these things? Graphing in general. 1, find your intercepts. X int is when y equals 0. Y int is when x equals 0. Y equals 0, which is f of x. So you set the function equal to 0 and you solve. Two. Find your asymptotes. BA is where the bottom is 0. HA depends on the exponents. It's important to know that vertical asymptotes are always asymptotes. But horizontal asymptotes are only asymptotes as x goes to infinity or x goes to negative infinity. They can be crossed near the center of the graph. And finally, we're going to do a sign chart. Like we did with inequalities. Positive regions, the graph is above the x-axis. In negative regions, the graph is below the x-axis. Because what we're doing is we're checking f of x, and f of x is really y. So when y is positive, you're above the x-axis, and when y is negative, you're below it. Those are the 3 rules for now. Till we get our other asymptotes, which are kind of neat. But I will segue into that with a good equation. Are you guys ready for a problem? Everybody online ready?
Yep.
Yes,
Jackie, how's the strawberry daiquiri going?
good.
I bet she is too. No, you're not. Well, no, her kid's home. I assume.
Yeah,
The
through the summer.
The delinquent. Alright, so let's take a look at an example. We'll do someone that's kind of simple at first. X plus 5, and I'll even give it to you in factored form. Because that's how I roll. But I'll write what it looks like if it's not factored. We multiply this out, we have an x squared, we have a minus x and a minus 2. So over here, I'm gonna collect a little box of information. My y-intercept is when x equals 0. F of 0 is 0 plus 5 over 0 squared minus 0 minus 2. 5 over negative 2. So 0, negative 5 halves, or negative 2.5. That's my y int. My x int. Is when y equals 0.
I think you're muted, Professor. We can't hear you.
How about now?
Okay, yeah, we can hear you now.
I wonder why the fuck I was muted. Rude. It powered off for a second. Okay, so you can always do y equals 0 is only when the top equals 0. So just focusing on, because like the bottom could be any number, but 0 over any number. Over any number. Is still 0. Unless the bottom's 0, then you're in some shady shit. So that's one way of doing, that's the safe way of doing it. If you want to get to it fast to find the intercepts, you can clear fractions. Alright, so. But that's not like endgame, we're not gonna just leave it as x plus 5. Because clearly, our next thing is our asymptotes, and we need to look at those. So where are my vertical asymptotes at? Vertical asymptotes is when the bottom equals 0.
And -1 and 2.
X equals -1 or x equals 2. Horizontal asymptotes. Rather than focusing on like which exponents are which, the thing I showed you with multiplying the top and bottom by the biggest exponent, that works here. The biggest exponent here is x squared. If I multiply this by 1/x² and 1/x², this becomes 1/x plus 5/x². The bottom becomes 1 minus 1/x minus 2/x². And the only reason I'm showing the long form of this is because it works every time, no matter what the asymptote is. Well, for the horizontal ones. And it's what you see in calculus. Then make x go to infinity. 1/infinity is 0. 5/infinity is 0. Anytime the x is on the bottom of a fraction, it goes to 0. This is 0/1, which is 0. So my horizontal asymptote is y equals 0. This matches up with the idea that bottom has a bigger exponent. If that's how you want to remember it, go with that. Eventually, looking and doing this x multiplying by large exponents thing is going to pay off in the long run.
Yeah, it proves that.
Yeah, and that's what you're going to use in calculus a lot. So if you make yourself more comfortable with it now, even though it'll be, it could be another 8 months till you're taking calculus in next spring. Or if you take pre-calc B over summer, you might be taking it in fall and it's not that far away. So HA is y equals 0. And now I'm going to do a sign chart. And I'm going to use the factored form. We had x plus 5 over x plus 1, x minus 2. When we did the inequalities, anything on the bottom, where it's 0 on the bottom, we got a hollow circle at. And anything on the top got a solid point. So solid point, hollow point. -2, -3, -4, -5. So I'm going to just break this up into regions and test values from each region. If I stick in 0, 0 is always the easiest one to do. 0, I have 5 on top over 1 times -2. The x's all go away. I've got a positive over a negative. This is a negative region. All right, now we gotta check our other regions. Look, I say like I tried 10 over here. 10 plus 5 is 15, that would give me a positive. 10 plus 1 is a positive. 10 minus 2 is a positive. This region is positive. So we've done this before, is when we had the inequality signs, it's been a while. But you've seen this stuff before. Here, -3 is in the middle. And if I do -3 plus 5, I've got positive. -3 plus 1 is a negative. -3 minus 2 is a negative. I got a positive or a negative and a negative. The two negatives cancel. This region is positive. And it looks like these are alternating, but you never want to guess. So just like plug in a really large number, it's negative. If I do -10 plus 5, that's a negative number. -10 plus 1 is a negative number. -10 minus 2 is a negative number. 3 negatives ends up being the overall region is negative. I need that information, so let me bring it back down. X equals -1 or 1. This should be x equals -1. I had +1 listed. All right. I am going to draw my axes. And at least where all my asymptotes and y-intercepts are at. Okay. I'm going to do my vertical asymptotes first. X equals -1. And x equals 2. My horizontal asymptote is y equals 0. Okay, so my intercepts. 0, -2.5. And -5, 0. That's all I've got other than my sign chart. And what happens asymptotically? So for numbers less than -5, I can see I have a negative, which means it's below the x-axis over here. And between -5 and -1 is positive. And as we get closer to the asymptote, it starts doing asymptotic behavior. I know we've talked about asymptotes before because it was in hyperbolus.
Well, question though. If we have a horizontal asymptote, how are we able to get through it?
It only applies for when x is going towards infinity or negative infinity. Close to the center, it's not, it doesn't count as an asymptote. Good question. So I didn't actually show it being an asymptote. It should come like this and start following that red line. I just had it going downward. I'm glad you said something. I was about to fuck that up. I know it crosses there, and I know it's got to follow the asymptote. All right. So here, between -1 and 2, the graph is all negative. And I know near the asymptotes, it's got to be following the asymptotes. Since it can't go upwards along this asymptote, because we don't have another x-intercept, it must be going downward. And it must be doing some shit like this, which means somewhere here curves around. I don't know where. We clearly have a turning point somewhere in there. Just like we talked about turning points last section, you'll find those in calculus. And my last region is positive. I know as it goes to infinity, it's got to be getting near that horizontal asymptote. And as it gets, since it's above 0, as it gets near here, it's got to be going along that asymptote. So it's doing some shit like that. You guys want to see it on decimals? Like it's crossing at -5 here. And it does go below. But then look at this, as it gets further to the left, it starts going back up to follow it. So I'm gonna zoom back out, come over here. I actually put in the equations for the asymptotes. And we can see it looks kind of like what we showed. Apparently on my picture, I made this go up much higher. And the turning point was more towards the middle, between the two asymptotes. But it's pretty close for a sketch, right? You guys want to try one? This is the only section we're doing today, so we got some time. I'm off screen, but great. Scrub up here. See. I plug in x equals 0. I got 1 or -4 times -1. 1/4. And the other one should be -1, 0. Those are my intercepts. My vertical asymptotes are at x equals 1, x equals 4. And since the denominator has a higher degree than the top, or if I multiply it out just to show you, we would have had x squared minus 5x plus 4. If I did 1 over x squared here, I get 1 over x plus 1 over x squared over 1 minus 5 over x plus 4 over x squared. And as x goes to infinity, 0, 0, 0, 0, 0 over 1, y equals 0. Got your sign chart. One is a asymptote, so we have a hole. 4 is an asymptote, so we have a hollow point, I should say. And -1 is a solid point. So maybe I'll try 2 there and 10 over here. We'll try 0 and maybe -10. If I stick in 0, I got 1 over, well, I already did stick in 0. I got it right up here. That's 1/4. We already saw that. That's our intercept, and that's positive. So this is a positive region. If I stick in 2, I have 2 plus 1 over 2 minus 4 times 2 minus 1. Positive over a negative times positive is a negative region. If I do 10, I should have positive, 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 which is a positive region. And -10 should be negative, negative, negative. And 3 negatives is a negative region. So now my y equals 0 or my x-axis is a horizontal asymptote. I'm just gonna do it as an asymptote in the first place and not have the solid line here. Then my y-axis is there. My other asymptotes are x equals 1. Two, 3, 4, and x equals 4. All right. I have a y-intercept at 0, 1/4, which is just barely above the x-axis. And I have an x-intercept right there. -1. So I know between -1 and -infinity, it's negative, which means it's below the x-axis, but it's got to come back up and follow the x-axis because it's an asymptote. between -1 and 2, it is above. So we'll make it cross at our y-intercept. And when it gets to this asymptote, it just has to follow it. It can't cross it. I like to think of asymptotes as the Tron cycle lines. If you've seen Tron, it's like that. Fucking, our Tron cycle tries to get to gets to the fucking next, the trail, and you're like, nope. Tron cycle takes a hard left, hard right, but similar idea. Follow the wall, don't cross it. All right, this is from 2 to, or 1 to 4. 1 to 4 is negative, which means it's entirely below the axis, which means it's got to follow. I don't know how far up it goes, but it's got to come back down and follow the asymptote again. And over here, greater than 4, we know it's positive. As it goes to infinity, it's gotta follow the asymptote. And since it's positive, as it gets close to x equals 4, it's gotta follow the asymptote there. Good times?
Yeah.
Alright. Next problem. F of x equals, let's see, 2x squared minus x minus 21 over x squared minus 2x minus 8. This should factor to 2x minus 7 and x plus 3. And this is x minus 4, x plus 2. So our x-intercept, well, let's do y-intercept. Y-intercept is when x equals 0. I've got -7 times 3 over -4 times 2. What is that, 21 over 8? That's fucking ugly. .625, I think. The x-intercept is when y equals 0 or when we set the top equal to 0. If we set the top equal to 0, we get x equals 7/2 or -3. So I have 7/2, 0, -3, 0. What are my vertical asymptotes here?
Or in maybe 2.
Yes. The horizontal asymptote, the short way of doing this is when they have the same degree or same exponent, you just take the coefficients out front. But just to give you some more like seeing the big picture where it connects to calculus, things you'll do in calculus. If I multiply by 1/x² on top and bottom, this becomes 2 minus 1/x minus 21/x². This is 1 minus 2/x minus 8/x². And as x goes to infinity, that goes to 0, that goes to 0, that goes to 0, that goes to 0. And we have 2/1. All right, we'll do a sign chart. In fact, I'm gonna do my sign chart as part of my graph. Our x-intercepts are part of it. Seven halves is 3.5. And we got -3 is the other intercept. And we had x = 4 was an asymptote. So that's like a circle point right there. And x = -2 was asymptote. Is that -3? Yeah, that's -3. Okay, so the regions we're checking is -∞ to -3. And then we're checking -3 to, I guess at -3 it's 0, so we'll use parentheses, to -2. Our next region is -2 to 3.5. And then we have 3.5 to 4. And then we have 4 to infinity. Those are all our different regions. So it's kind of like we need to check right here. Even though there's no asymptote there, that's where we have an intercept. And we gotta check right there. And I'm gonna plug them into this. Let me rewrite it down here. I know I have a horizontal asymptote at y equals 2. I'll put that in as well. Okay, if I stick in x equals 0, I have the y-intercept. The y-intercept was 0, 21.8, it's positive. So this is a positive region. In fact, 21.8 was above 2, but below 3. So I have my point up there. If I stick in 10, like if I try x equals 10, 2 times 10 is 20, 20 minus 7 is 13, that's positive. And all of them tend to be positive right there. So this is a positive region, we're gonna be up above. And if I stick in negative infinity or negative 10, I've got a negative, a negative, a negative, a negative, which makes the overall region positive. We just need to figure out what's going on right here and right here. That's not a very big window. Let's try negative 2.5 there and maybe 3.75 over here. So negative 2.5, the first one's negative. Second one on top is positive. The lower left one is negative. And the lower right one is negative. So this is a negative region. And if I check 3.75, that's like 2.75 times 2 is 7.5. 7.5 minus 7 is positive. And then the plus one is a positive. This one's a minus, but that's a positive. This is a negative region also. Okay, so now we've got to follow the asymptotes. So let's start on the left. Does it cross anywhere in here? Let's see. We can see where it crosses y equals 2. Does it cross our horizontal asymptote? Well, set f of x equals to 2 and solve. Which here is going to be a pain in the ass. So if I get a common denominator. I have 2x² minus x minus 21 over the bottom equals 2x² minus 4x minus 8 over 16, minus 16, I should say, over the bottom. And now we only need to worry about the top. So minus 2x² plus 4x plus 16. I'm gonna make the right side equal 0 here. And I have 3x minus 5. So it crosses at x equals 5/3. Crosses HA here. Five thirds is almost 2. So it's gonna cross there. And that's the only spot it crosses. Five thirds. All right, so now we can connect our dots. I know the asymptotes, vertical asymptotes can't ever be crossed. So it looks like this is doing some shit like this. And it never crosses the horizontal asymptote again, so it must be going up. And this one crosses here at our x-intercept. And it must come down. And that seems to match our plus and our minus up here. Right? That matches our plus and our minus. This is all positive, this is negative. I guess if I was paying attention to my sign chart, I wouldn't have needed to do this, where does it cross? But if you really want to know where it crosses, that's how you find it. All right, over here. Between -3 and -2, it was negative. Which means it's below the x-axis, which means it's got to be following it like that. To the left of it, it was positive, but we know it didn't cross the horizontal asymptote again. And over here, it was positive, so this is again doing some shit like that. So one good thing about doing where does it cross the horizontal asymptote by setting the function equal to it is I know that this doesn't do something like this. It doesn't go above it and then come back down and follow it like that. Does that make sense? So like it could have been something like this and then came back down and followed it. And this could have done something like this and then came back up and followed it. But by checking where it crosses HA, I know that this one is out and that option is out. Does that make sense? If I were sketching it. The y=0 one where the asymptote was like the x-axis, we already had the sign chart, so that was easy. We didn't need to do this shit. But here, this tells us that. like where it actually crosses. We can go look at it on Desmos. I got this plotted. That's the one we looked at before. We throw in our asymptotes. And that looks like what we got, right?
So I guess I'm still kind of confused about the part where we figured out 2 is the intercept through the asymptote. What are we, how are we figuring that out? I got lost there.
So I know that the horizontal asymptote is at y equals. I know the horizontal asymptote is where y equals 2. Y is actually f of x though. So if I plug in f of x equals 2, I make this right side equal 2. And now all I've got is x's, and I can actually figure out what x's work to make the right side 2 by solving.
Oh, okay, so you just set up the equation.
Yeah, it's very much like how when we're finding our roots or our x-intercept, we set f of x equal to 0. And the reason why we're doing that is because y equals 0 and that's the x-axis. And we solve to find our roots there. Same premise, but now we're not on the x-axis anymore. Does that make sense?
Yeah, like it's kind of making sense.
Like everywhere on this line. Y equals 2, f of x equals 2.
Right.
So to find out which x values work, we can just plug in our y equals 2.
Oh, okay, so it's because, so we're plugging in there and then we're solving for that. So what we-
Yeah, that is our y equals 2 line.
So there will only, because it's a flat line, there will only be one spot that is pierced.
Not because it's a flat line, it's because when we solved and cleaned up, we actually lost our x squareds. It could have crossed in more than one spot.
It was
Yeah.
more than one spot if we had. If it was like x to the third and x flat on one side, if it was imbalanced or one side was greater than the other.
Right.
It might express itself that.
The next one we're gonna do is the slant asymptote, which tends to have more crossings of the horizontal axis. If there is one, or more crossings of the slant asymptote. All right. So, introducing the last topic. When the top is bigger than the bottom. By only one. This leads to something called the slant asymptote or oblique asymptote. To find the equation for this. So it's a line. It's at a slant. So this is like we can get a y equals mx plus b kind of thing. To find the equation for the asymptote. We do polynomial division. Okay, 2 ways of going about it. If the bottom is in the form x minus c some value. And I'm going to specifically indicate 1 x minus c. You can do synthetic division. Which is the easier route. Any other form. we have to do polynomial long division. We're gonna do as much as we can in this, but we actually did this for an hour in Math 335 earlier. So, you can always watch the video for that later on. In fact, in Math 335, we covered where top was bigger by 1. And then bigger by 2. This one gave us something like that for this one. Bigger by 2 gave us a parabola for our asymptote. So it's really like what we did on Tuesday, we talked about end behavior. This whole asymptote idea is what's going on with end behavior. Let's do some examples. I'm over here trying to rush ahead and Sarah's still writing. She wasn't gonna say shit, she was just gonna let me take that page. Yeah, tell that Jones to knock that shit off, Sarah. Say, knock that shit off, Jones, I ain't done writing. All right, now you're not done. Now you're not writing. Actually, I'm gonna lead into it with something else. Well, this is the same scenario. Okay, so I want to note that if we factor, this is x times x minus 1 over x. And if these were any two other numbers like not x, we could cancel and just say this is x minus 1. When we do our long division, we're going to get x minus 1. But this says vertical asymptote at x equals 0, right? So when you can cancel an asymptote on top, when you can cancel by simplifying. It's no longer an asymptote. But we still can't use that value. So which makes a hole in the graph. I'm just gonna go straight to, I told you it's gonna look like y equals x minus 1. Before we actually get to doing all the work, I'm gonna show you. It looks identical to y equals x minus 1. That's the equation we're looking at. That's a fucking line. There's no curve. It's a straight line the whole way. But we would have had an asymptote at x equals 0. 0 is undefined. And Unfortunately, it doesn't matter how much I zoom in on Desmos, you will never see it. No matter how close I fucking get,
Just,
it still looks like a continuous line. The only time you see it is if you put the cursor over it and show that it's undefined. It's crazy, right? So in terms of doing vertical asymptote, we don't have them. We have a hole at x equals 0 instead of VA. Here, the numerator is bigger, and we can divide doing polynomial division. We did this before. Negative x divided by the number out front is -1. -1 times x is negative x. Then I subtract it and I get 0. And we're done. So that's what we're left with. Which we just got by canceling out. Sometimes you can't cancel out, but in this one, it just canceled out. So I was showing 2 birds with 1 stone there. We saw the graph of this. This is the graph of y equals x plus 1. Let's do one that's or x minus 1 with a hole at x equals 0. Let's do one where it doesn't cancel, but there's still a slant asymptote. Let's take a look at f of x equals x squared minus x minus 6 over x plus 3. And if you want to factor it, you'll see that no, nothing cancels out. When x equals 0, what do we have? We have -3 times 2 is -6 divided by 3. We have 0, -2 is a y-intercept. And we should have x-intercepts at 3, 0 and -2, 0. Just by setting the top equal to 0. Intercepts. What's my VA here? X equals -3, yeah. Now here, we're not gonna have a horizontal asymptote, that's out. We're gonna have an oblique asymptote. I could use synthetic division here because there's a coefficient of 1, but I'm not going to. Because I want you to see the polynomial division more. How many times does the large thing on the outside divide into the large thing on the inside? X. We did this like 4 or 5 times in Math 335. So if this is, you're a little rusty on this, watch that video later. I'm pretty sure we did polynomial long division before. When I introduced synthetic division. Then we take x, multiply by x plus 3, we got x squared plus 3x. Then subtract. I get minus 4x, bring down the minus 6. And we do the outside big term divided by into the big side inside big term. -4. Multiply the -4 times the x plus 3, we got -4x minus 12. We're gonna subtract that, so I'll change the signs inside. And I'm left with the 6. Which means x squared minus x minus 6 over x plus 3 is x minus 4 plus the remainder over the old denominator. This is our slant or oblique asymptote.
Does the remainder affect that or
No,
just?
because just like horizontal asymptotes only applies as x goes to infinity.
Center.
Right, and in fact, we make cross in the center. In fact, does it cross? This is our f of x. So I'm going to set f of x equal to that. Since I'm only looking for where it crosses and I'm not worried about asymptotes right now, I can just clear fractions.
Sure.
Minus 4x plus 3x is minus x. And I got minus 12. I get -12 equals -6. So I didn't get an x value, so it doesn't cross the slant asymptote ever. We'll make a little sign chart real quick. And +3. This is a solid point. That's a solid point. That's a hollow point. I know 0, -2 is a point, so this region is negative. We already found the y-intercept. So if I plug in like 10. This is positive, 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 that's a positive region. If I try -2.5. I have a negative on top, another negative on top. Positive on bottom, this is a positive region. And if I plug in like -10, these are all negatives. So that's a negative region. All right, you with me? You all right, Sarah? You look so happy. All right, let's put this shit together on a graph. We have a vertical asymptote at x equals -3. And we have a slant asymptote. If I did a little bit better on the spacing, this would look more diagonal. That's y equals x minus 4. Those are our two asymptotes. Our actual graph crosses at -2 and +3 for the x-axis. And 0, -2 on the y-axis. We know it never crosses the slant asymptote because we checked it. So between -2 and 3, it's negative. That looks like that follows pretty clear to this, some shit like that. From 3 onward, it's positive and it follows, it starts following the slant asymptote as it goes away. Between -2 and -3, it was positive, which means it's got to be going up like that. And to the left of -3, it was always negative. So as it gets close to this asymptote, it's got to be negative, which means it's got to be doing some shit like this. And then as it goes towards the slant asymptote, we know it never crosses, it does some shit like that. And I got this one ready for you on Desmos so you can see it also. I gotta zoom out. I'm fucking way zoomed in. Fuck. And I didn't put in y equals or x equals -2. Do I have that up here? I do. I'll turn it on. Wait. Was it not -2? No, it's -3. Change that to -3 real quick. There, now we can see it's following the asymptotes. All right, one more that's a little complicated, more complicated, but not too bad. It's again, only gonna be 1 degree higher. We're gonna do f of x. I'll give it to you in factored form. So x-intercept, y equals 0. It's where the top equals 0. X equals 1/3 or x equals 5/2. Y-intercept, x equals 0. I've got -1 times -5 divided by 1 is 5. So my intercepts are 1/3 0, 2.50, and then 0, 5. Those are my intercepts. What's my vertical asymptote? How do I find vertical asymptote?
Set the bottom of the equation equal to 0.
Yeah. R oblique asymptote. I need to multiply this out. That is 6x squared minus 2x minus 15x plus 5. So I got 6x squared minus 17x plus 5 over 2x plus 1. Synthetic division will give you the wrong answer here, because that too. If you don't believe me, watch the Math 335 video. We did one both ways and showed that you get different answers. So we gotta do some long division here. Six x squared or divided by 2x is 3x. Boom, 3x. We multiply, we get 6x squared plus 3x. And I will subtract.
And wasn't, I'm sorry, question, isn't there a rule as to when we can use synthetic division versus when we have to use long division?
Yeah, the bottom has to have a it's gotta be only first degree, only exponent of 1. And the coefficient has to be a 1 in front of it. It has to be an x minus c form. And you can see if you see that video, then I should see why. Now we're gonna divide 2x into negative 20x. And we subtract. Which changes the signs when we put them inside. And I'm left with the 15 left over. We're lower than the exponent on the outside, so we're done. That is our oblique asymptote, y equals 3x minus 10. Do we cross the oblique? Take your equation and set it equal to the oblique asymptote. So I'll multiply through by 2x plus 1. On the left side, it cancels out. And if I distribute this, I get 6x squared. I had minus 17x plus 5. We already knew that because we did that earlier up here. Over here, I have 6x squared. I've got minus 20x plus 3x is minus minus 17x again. And then minus 10. Subtract 6x squared and add 17x to both sides. And I get 5 equals negative 10. Which is false. So no crossing. Y equals 3x minus 10. It's a true asymptote. We only have 2 minutes left, so I want to just say what you would do on the rest. Do the sign chart. Find your positive and negatives. You have your intercepts up here. You have your asymptotes. You have intercepts and asymptotes. And with the sign chart, you can grab it. Just like we've done with the other ones. I thought I'd show it to you on Desmos real quick. That is our equation. And we can see our asymptotes like that, and it never crosses it. Great. Was that fun? If there is a slant asymptote on the final, it'll be an easy one. Probably with like a y equals x kind of thing rather than a fucking steep one like this. If I might just do a horizontal asymptote. I don't know, I haven't decided yet. Be ready for either because I'm a crafty one. Well, if you try other ones that are non-linear where they have weird stuff like when you grab this one, it does shit like that. But when you do polynomial division, you get that. And while it does cross it right here, it crosses this asymptote right here. As you zoom out, left and right, it looks like the fucking asymptote. It's following like the parabola x squared minus 4. And that's what you would have get if you'd done long division right here. So it's kind of neat. We did an example kind of like this in 335. So if you want to see long division where you end up with something like this, check it out. Other than that, have a good day.
Mr. Jones.
Yes.
I will not be in class on Tuesday. Yeah, I won't be in class on Tuesday. My daughter has a dentist appointment. Today's dentist appointment took 2 hours. And then I
Okay.
have a Mesa award night as well.
Nice, congratulations.
Thank you. So
I thought that was on Thursday.
No,
It's on
that's the
Tuesday?
7th. Yeah, today is scholarship night for those like who
Alright.
applied the scholarship, and I got one of those too, so I'm super stoked. So just let you know, I won't be here on Tuesday.
Right.
Thank you.
Where'd you get your scholarship from?
Let me see. I got 2 of them.
Wow.
Where'd you get it from? Go look at them.
Hold on, give me 1 second. Let me look at it real quick.